All right, so this is the June 2024 part 2. We would have gotten 20 times 2, which is 40 points, and a 76 so far just with the part 1. Let's go ahead and earn some points on the part 2. Okay, so question 25 is one that we could definitely do. So here it looks like we're just going to have to FOIL. So x times 3 is 3x. X times negative 2xi is going to be negative 2x squared I. Cool. And then we add this, so that's going to be 6i, so plus 6i. And then over here we're going to get negative 4. Looks like it's going to be xi squared. And then we're going to add this to 2x squared I. Okay. So we want to put this, it says in real numbers, and then the expression put it into a plus bi form. So we know we're going to have to do some simplifying and combining here. All right, so do we have any other x squared i's? Yes, we do. So this 2x squared I and this 2x squared I cancels each other out. So we're left with 3x plus 6i minus 4xi squared. Okay. So we know right now that I squared, right? If you plug that into our calculator, let me do that real quick. My calculator turned off. I squared is the same thing as negative 1. So instead of my I squared here, I can type in negative 1. Let me bring down everything else. So this is plus 6i and this is 3x. Okay. So what does that mean? That means that this is plus 4x because negative times a negative is a positive. This 6i comes down, and then I have the 3x, and now I'm just going to combine like terms here. So that's going to be 7x plus 6i, and that is in a plus bi form. So that's my 2 points. Okay. Question number 26. You could definitely do this. So watch. Very simple. If my computer would cooperate. Cool. So first thing I want to do is divide both sides by 3.8. Divide both sides by 3.8 because I want to get the weird thing by itself. So when I do that, this cancels out. So I am left with e to the 1.5t is equal to 16 divided by 3.8. And yes, I know I can plug this into my calculator, but let's do get rid of our ln first. I get rid of our e. So we get rid of e by lning both sides. That allows us to cancel the ln and the e out. So I'm left with 1.5t is equal to ln of 16 over 3.8. How do I get rid of the 1.5? Divide everything by 1.5, divide by 1.5. And this whole thing can go into a calculator. So let me just show you how to do that in case you're not sure. So I have ln. I'm going to put alpha y equals option number 1, put my 16 on the top, put my 3.8 on the bottom. Okay. Cool. And then I'm going to alpha y equals this again. I could have done 2 fractions and I divide this by 1.5. And so my answer is going to be about 0.9, and it says rounded to the nearest hundredths place. So this is 0.96. So our t is, and I could use the symbol for about 0.96, and that's my other 2 points right there. All right, we are cooking with gas. 27, definitely one that you could do. In an attempt to get to the student body's opinion of new dress code, members of the stats class surveyed the students of the first period computer science class. Interesting. They did not sample everyone. Explain a statistical bias. Cool. So a bias could be um, the opinions of the first period comp sci class, right? It may not be, not, let's just say, represent the opinions of the whole student body. Whole student body. Forgive my handwriting, but I'm saying it to you. So I'm going to count 27 because 27 is kind of like a common sense one. All right. Question 28, it says p of x, so this is one that we could do, has zeros at -5, 1, and 4. So negative 1, 2, 3, 4, 5. At -5, there's a 0. At 1, there's, nope, that's not 1. It's -1. At 1, there's a 0. And 1, right? At 1, 2, 3, 4, there's a 0. Okay. So I'm going to label that -5, 1, and 4. I want to make sure I get all my points. It says as x goes to the right, which means here's our x, right? As we go to the right, that's positive infinity. So as we go to the right, our y goes down, right? Our y goes down. So as we go to the right, our y goes down. Okay, cool. So right, y down. Okay. And then as we go to the left, what's happening to our y, right? Our y is also going down. Our y is going down. Okay. So what does that mean? It has to go, our graph is going to look something like this. It's going to hit our 0. Okay. It's going to come down. It's going to go through this. Right. It's going to go to 4. It's going to come down. Okay. But we know that as we go to the left, it has to go down, and as we go to the right, it has to go down. So that's why we're not starting up, right? We're starting it down, and it hits at -5, and then it has to go right through 1 and 4. So this is the way that our graph can look. Okay. If I flipped it and went something like that, that would not work because, right, it says that as we go right, our y has to go down, not up. Okay. So it's going to look something like that. All right. So this question we counted. Question number 29. Da 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 da. We're going to skip that one. We did not do that yet. Question number 30. You should definitely be able to do. Okay. Put this over 1. We got to get our denominators to be the same. So our least common multiple here is going to be an x and an x plus 5. So here there's an x plus 5. What's missing is the x. So I got to multiply the top and bottom by x. Here we have the x. What's missing is the x plus 5. X plus 5. And over here, both of them are missing, an x and an x plus 5. So I got to multiply the top by x and an x plus 5. When I do that, right, I take out my red marker, the whole bottom goes away. So what do I have here? I have x times 8 is 8x. Then I have a minus sign. And then I have 3 parentheses x plus 5 equals 5 times x and x plus 5. So now it becomes an algebra 1 problem. Let's distribute that. So 8x minus 3x minus 15 equals 5x times x is 5x squared plus 25x. Okay. Be good. Let's get everything to one side. So these combine to give us 5x minus 15 is equal to 5x squared plus 25x. Let's move this over. So minus 5x plus 15 plus 15. This cancels out. So I'm left with 5x squared plus 20x. That looks right. Plus 15 equals 0, or you can put the 0 on the other side. I see that 5 goes into all of these, so I can divide everything by 5, so I don't have to do no AC method here. So I get x squared plus 4x plus 3 is equal to 0. Okay, not bad. So I get x plus 3 and x plus 1, right? Two numbers that add to be 4, multiply to be 3. Set them both equal to 0, and I get x equals -3 and -1. Okay. Now we got to check it. So let's check to see if this is right. X equals -3 and -1. So if I go back to my original and I plug in, I want to see if this is going to give me a 0 if I plug in -3. It's not. Is this going to give me 0 if I plug in -3? It's not. That means that -3 works. Okay. And do the same thing for -1, right? -1 plus 5 does not give me a 0. And if I plug in a negative 1 here, that also works. So that means that my two answers are x equals negative 3 and negative 1. So I definitely count this question. Question number 31, we can skip that. We did not do that. Question 32, can this function be considered odd? Okay, so remember, odd means that if I take my, it has to go through 0, 0. And if I take my paper and I turn it around, um, like rotate it 180 degrees, it's going to give me the same function. Okay. Da, 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 da. All right, so I went ahead and I plugged in my function into my calculator, and it does not go through 0, 0. I could also test it because if I take my coordinate, right, like if I have uh, 0, 7, and I take 0, comma 7, and I switch it to get 7, comma 0, it has to go through that point. And let's see if it does. 7 does not, right? 7, 0 does not, is not part of our answers. So this is not odd. So we want to say no, it's not odd because 180-degree rotation of an odd function would map it onto itself, and x to the third plus 7 does not, right? It does not map onto itself. Okay. All right, next one. So this one is a polysymbol 2 question. Okay. If you get your answers for this, you get your x equals, if you use your calculator, and you get x equals negative 2, and you get y equals 6, and you get z is equal to, what's z equal to? Negative 3. And again, polysymbol 2 will do this. Then you will only get 1 point out of 4. Okay, so how do you do this the part 2 way? The part 2 way is you start with two of them, two of the functions, and you get one of the variables to cancel out. Okay, so none of these right now look like they can easily combine to cancel any of the variables out. But let's just say if I work with these, right, here's function 1, here's equation 2, here's equation 3. If I look at 1 and 3, if I multiply the top one by positive 2, that's going to give me 6x, and then that'll allow this negative 6x and the positive 6x to cancel each other out. Okay, so let's do that. Take 2 times 3x, I get 6x. 2 times negative 8 gives me negative 16y. 2 times 2z gives me positive 4z. And again, all I'm doing is I'm distributing here. Is equal to 2 times negative 60 gives me negative 120. Okay, so that's my first function. And I'm going to add it to the third equation. Negative 6x plus 2y minus 4z equals 36. Okay, if I do that, boom and boom, boom. Okay, two of them cancel out. That's great. So now I have negative 16 plus 2y. That gives me negative 14y is equal to negative 120 plus 36 gives me negative 84. Divide both sides by negative 14, divide both sides by negative 14, and I get y is equal to 6. Okay, so y equals 6. I solved my first one. All right, so now what does that mean? That means that I can take that y equals negative 6, the y equals 6, and I can do something with it, right? Let's see. Okay, so I can take my function here and I see that I have y equals 6. I'm trying to see if there's an easy one that I can plug it into. Okay, so if I take, all right, so I have to plug it into, do two other functions, right? So for this one I used 1 and 3. I cannot use 1 and 3 again. Why don't I use 2 and 3? Okay, so equation 2 and equation 3. So let me go back to this right here, get rid of this. So my equation 3 is still negative 6x plus 2y minus 4z is equal to 36. And I have to get my x's to cancel out. I know my y is equal to 6 now. Okay. Can I see if I can get, yeah, let's get my x's to cancel out here. Okay. So how do I do that? I have to multiply this top one by positive 3. So let's do that. So I get 6x minus 21y minus 15z is equal to negative 93. Cool. Now these cancel out. All right, so now I have negative 19y minus 19z is equal to negative 93 plus 36. That gives me negative 57. All right. But I also know that I can, the negative 19. Okay, so negative 19 goes into all of these, so I can divide everything by negative 19, divide by negative 19. And if you didn't know that, that's okay. You could just go ahead right here and just be like, okay, hey, y is 6, right? Let me just do this in a different color. Y is equal to 6. So wherever I see a y here, I can plug in 6. So negative 19 times 6 minus 19z is equal to negative 57. So I can plug this into my calculator. You all know how to solve this. You know how to solve this. Negative 19 times 6 is equal to negative 114. So I have negative 114 minus 19z is equal to negative 57. Let's move some things over. So add 114, add 114 here. This cancels out. So I have negative 19z is equal to negative 57 plus 114. So I get 57. And then I divide both sides by negative 19. And I get z is equal to negative 3. All right. So now I have z equals negative 3. I have y equals 6. All right. And then I just want to find x, so I can choose any of them. So let's go with the first one. So 3x minus 8y, but I know that y is equal to 6, so I can plug in a 6 there. And I know this is plus 2 times z, and I know that z is negative 3. We just found that, and that's equal to negative 60. You could solve for x here, and you can get that x is equal to negative 2. Okay, so there's our answers, and this would be 4 points. Okay, that was a while. It's all good. It's all good. All right, question number 34. As soon as you see average rate of change, y2 minus y1 over x2 minus x1. Okay, none of this is hard. It says prices since 2008. So T is the number of years since 2008. So how many years is 2010 since 2008, right? That is 2 years. How many years is 2018 since 2008? That is 10 years. So we want to find, right, for 2 and 10, what our y's are. How do I do that? I go to my calculator, right? They gave us a function right here. So I'm going to go to my calculator. I'm going to type that function into y equals. So I have 200,000 parentheses 1.045 close parentheses to the t. Instead of t, we're going to use x. And then I'm going to hit second graph. And I'm looking for the number across from 2. Right? So I have this number right here. I have 218,405. So I have 218,405. And then I'm looking for the number across from 10. I'm going to go down. Hopefully it'll let me. Here we go. Across from 10, I have 310,593. 310,593 point, and I have some numbers here. I have 88. Okay, so since this is money, I can just round that there, and then I can do my formula, right? X1, Y1, X2, Y2. So I could do 310,593.88 minus 218 405 all over 10 minus 2. And this is something that I can plug into my calculator, right? So let's get rid of this, clear that. Alpha y equals, right? You see what I'm doing? I'm just plugging in the whole thing. So 310,593.88 minus 218, 405. Then go to the bottom, 10 minus 2. I know that's 8. And then I hit enter and I get 11,520, and it says rounded to the nearest dollar. So this is 11,524 to the nearest dollar. That's our answer for the first part. Okay, that is 2 points. All right. Explain what this rate of change means as it relates to median house prices. So that means from the years, right? 2010 to 2018, the median house price increased $11,524, right? Per year on average. So the average median price increased by 11,524. Okay. Skip number 35, 36. I was going to be like, well, there has to be a graph question, and there is. Okay. So I'm going to go to y equals here. Let me just reset my calculator. Second plus 7, 1, 2. All right, let's go to y equals, and let's punch in our function math. Go down to log base because I have a 2 there, and then I do x minus 1, go to the right, and then plus 3. All right, so now since this says graph and not sketch, I have to be very precise. So 2 comma 3, 2, 3, there's a dot, right? So I'm just graphing this. And then at 3 comma 4, so 3, 4, there's a dot. You see what I'm doing, right? I'm using every single number, 5, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? Starts getting a little bit more sporadic. 9, 6. So 9, 6. Okay. So I'm going to just go ahead and verify this by looking at the graph. Okay, that makes sense, right? So I know across, so my right here, I know that I have to continue my graph. So somewhere between 1 and 2 is when it goes through 0, right? And the x-intercept is there. So I can go ahead and it looks like it's a little bit past 1. So I can go ahead and graph this by going like this. And I go a little bit past 1, and that's where my asymptote is right here, right? So this right here, you can do your best, maybe a little bit better than me. And you're going to show that it doesn't cross 1. So I said the word asymptote, right? Asymptote is the line that the graph never crosses. And I just showed you right now that since it gets very close to 1, my equation of my asymptote is going to be x equals 1. Okay. Why? Because x equals 1 is where the graph never, right? It never goes like this. So I'm going to write my x equals 1 is my asymptote, and then it says when f of x is reflected over the line y equals x. Okay. So now that, what does that mean? Y equals x is a straight line. Looks something like this. So then it says when it's reflected over the line y equals x, a new function is formed. And that is 2 to the x minus 3 plus 1. And it says state the equation of that line. Okay, so let's go to here. Let's type that function in. So we have 2 to the, and then it's x minus 3. And then I have plus 1. So we want to know the asymptote of this line. Okay, and that is a horizontal asymptote if I ever saw one. Yes, it is. It is a horizontal asymptote, and it looks like it doesn't cross where 1 is. Now let's verify that. Let's go to my function here. Do you see these numbers? You see these numbers in red? You see how it's getting very close to 1, but it doesn't go to 0, right? If I keep going up, it might, right? You see that? It's approaching 1. So 1.002. If I keep going up, it's like 1 point, right? So that means that my horizontal asymptote, it is a horizontal asymptote, and it's going to be at y equals 1. There we go. That's our 2 points for question numbers. Well, that's our 4 points for question number 36. Okay. Question 37. This one looks crazy, but it's not. It's not crazy. So it tells you that the air temperature is a constant of 73 degrees Fahrenheit. That's how much we start with. Okay. That, if I look and see, that's the air temperature. So that is my TA, just labeling everything that I see. And the liquid is 237 degrees. So that is my initial. So that's my T0. 1.5 hours later, right? So this is 1.5. The temperature of the liquid is 112. So 112 is my temperature of the liquid at T hours. So this is my T of T. And we have a function right here. So what we're going to do is we're going to plug the numbers that we have in. So my T of T is 112. My T, what is this? It says TA. My TA is, I think I wrote that as 73. So I'm going to put my 73 here. Then I have a plus sign, right? All I'm doing is I'm following this formula, parentheses. My T0 is 237 minus my TA. My TA again is 73. Then it says E to the negative my K. What's my K? My K is my constant, right? So I'm going to leave it as K. And then my T is time, and I know my time is 1.5 hours. So it's going to be negative 1.5, and don't forget your K. Okay. Now it says determine the value of K. It does not tell me to do this algebraically, so I could go y1, y2, and figure that out. Okay. But if you're like, I want to do this algebraically, let's subtract 73 from both sides. This cancels out. So 112, let's go to our calculator here. Get rid of this. 112 minus 73 is equal to 39. So I have 39 is equal to 237 minus 73 is 164. So I have 164 e to the negative 1.5k. Let's get rid of that 164. Divide both sides by 164. Cancels. So I get 39 over 164. That's a 4. Is equal to e to the negative 1.5k. I know I can get rid of my e by doing ln on both sides. Cancels out. So now I have ln of 39 over 164 is equal to negative 1.5k. To get the k by itself, divide both sides by negative 1.5. And this is something I can put into my calculator. So just like before, right? Alpha y equals option number 1. You can do ln. Cool. I have another fraction, alpha y equals. Just showed you 2 different ways to do this. 39 over 164. Close our parentheses. You don't have to, but let's just do that anyway. And then I have k is about 0.95, and it says to the nearest thousandth, so k is about 0.958. So round it to the nearest thousandths. Okay. All right. Then it says determine the temperature, and again, this does not say algebraically. After 2.5 hours. Okay, so now we know what our k is. So let's go to our function again. So I have 73 plus 237 minus 73 e to the, and it says determine the temperature of the liquid using your value for k after 2.5 hours. So I'm going to do, our k value is negative 0.958. I'm going to multiply that by 2.5 hours, and I want to see, right? There's no unknowns here. So this whole thing, I can just take this whole thing and plug it into the calculator, and this is going to give me a number that is about 88. Okay, temperature of the liquid, so about 88 degrees. All right, and then the last one, Megan needs the temperature to be 80 degrees. So the 80 degrees is what's going to go. That's our T of T is 80. To perform the next step, use your value for K. So we know that K was about 0.958 to the nearest tenth of an hour. How much time? So now we need to figure out how much time she must wait. So still 73 plus, it's still 237 minus 73, right? We're still following that formula. It's e to the, we still have our value of negative 0.958 because we're using our k value, and we're looking for our time here. So subtract 73 from both sides. That gives us 7 is equal to 237 minus 73, right? We already did that in our calculator. Yeah, so it's 164. E to the negative 0.958 t. Divide both sides by 164. Divide by 164. Cancels out. So I have 7 over 164 is equal to e to the negative 0.958 t. My t is in the exponent, so that means that I'm going to have to ln both sides. Right? ln, you get the point. You get the vibes. So I have negative 0.958k is equal to ln of 7 over 164. Divide both sides by negative 0.958. Divide by negative 0.958. And again, this is something is long. I get it. It's long. I can go up and grab this because this is similar to what I have to put in. So now I have 7 over 164. I already have this, so let's delete that. Let's put a 7 in its place. Then I'm going to go down, and over here I'm going to type in negative. Let's delete this. 0.958. Hit enter, and I get that this is about, what do they want me to round to? To the nearest tenth. So K, have I been saying K? Wait, this is T. T is about 3.3. Right? That's what my calculator gave me. This is about 3.3. So that whole thing is 6 points. All right, completely doable. Great job. Thanks for sticking with it. About 33 minutes or so for this video key. I just want to show you real quick. Let's see. So how many points would we have gotten? 20 times 2 is 40. Let's add to that another 6 points right here. So 6 plus 4 plus 4. 6 plus 4 plus 4 is 14. Plus another 4 right here is 18. This is 2, 20, 22, 24, 26, 28, 30. So that's another 30 points. So let's add that up. So our 40 points from the multiple choice plus another 30 points from our short response questions is 70. And what would a 70 give us? A 70 on the June would have given us an 87. What? Are you kidding me? Are you kidding me? Okay, so that is pretty good. Overall, right? 70 would convert to an 87. I'll take an 87. Why not? All right, good job. I'm gonna stop talking now.